Okay, now I'm going to take the notes for the lesson 10-7, the area of a circle, the inside, obviously, space of a circle, as well as sectors. So we'll talk about what sectors are in a second. So there are sectors and there are segments of a circle. This over here to the far right, this is called the sector. It's kind of like a slice of the pie, slice of the pizza. And this little cap here is called the segment. And we'll go over the area formulas for both of them. Really, there's only an area formula for the sector. The segment you got to calculate a different way. Let's go to the basic formulas. The area of a circle, we should all know by now, is pi r squared. So if I want to figure out all the space, the shaded region inside a circle, you figure out the radius, square it, and multiply it by pi. But what about the area of a sector, which is, this is a sector, just a piece of the pie. Well, we need to figure out what percent that slice is compared to the entire circle. So it's going to be, and here is the big formula for the day, excuse me, the arc degree. There will be a degree with that sector. We're going to divide that by the entire circle is 360 degrees. So that will give you the percent of the circle that is represented by that slice of the pie. And instead of multiplying by the circumference, we are dealing with area inside, so we're going to multiply it by the area of a circle, pi r squared. All right, and that is our major formula for the day. So let's go to number 1 here. Find the area of the sector. All right, so how big is that slice of the pie there for number 1? So the formula again is the degree, the arc degree, over 360, multiply it by the area formula of a circle, pi r squared. The degree there is 100 degrees, or you can look at the center angle, over 360, multiply it by pi. Radius is 6 squared. So I went through this already. This is 0.27777. 100 divided by 360 is 0.277. So the circle, the shaded region is 27% of the circle. 6 times 6 is 36 pi. This thing ends up being 10 pi. That is the area of the sector. We would call this meters squared. Or if you don't like the pi symbol, we can multiply it out, and this would be 31.4 meters squared because we're dealing with area inside. So when you say meters squared, there are 31.4, these little squares that fill in this shaded region here. I'm not going to draw them all, but that's essentially what that meters squared represents. Okay? All right, let's move on to segments. So we're going to figure out the area of the segment, which is this portion right here at the top. And so the way we're going to do this is not use one particular formula. We are going to solve this with some basic logic. In order to find the area of this segment here, I'll shade it in yellow. The logic being, what you're going to do is figure out the area of the entire slice of the pie as if everything was yellow, and then you're going to minus out the triangle here. And if you minus out the triangle, you're left with just the yellow portion, the segment at the top. So the formula for the area of a sector, we're going to take the sector first, and then we're going to minus out the triangle. The area for the sector is, you got to take the sector degree, which is 120 degrees over 360, and multiply it by the area of a circle, which is pi 24 squared. I did all these calculations already, but basically this ends up being 603.2, the area of the sector, as if everything was yellow. And then we're going to minus out the area of the triangle. Now this is not a traditional triangle. This is a 24, a 24, and 120 degrees there. We're going to use this formula 1/2 b times c times sine of a. So in this case, it's going to be 1/2 24 and 24 because they're both radiuses. don't like the sound of my pen right now, times the sine of 120. I'm saving us time. I know the area of the sector was 602, and the area of this triangle, if I punch all that into the calculator, is 249.4. You subtract the sector minus the triangle, you end up with an answer of 353.8. And this would be feet squared. And that is the area of the segment here in red. All right, but the logic is to figure out that segment, you take the sector and minus out the triangle. The triangle is a bit tricky. You got to use this formula right here. 1/2 side times sine of A.